Hi Year 11 Mathematics Advanced students. Today we're continuing on with the topic of functions and we're doing finding a quadratic equation. So parabolas are used in real world contexts such as bridges, satellite dishes and car headlights. We're going to look at some examples in order to find equations of parabolas or quadratic functions. So we want to find the equation of the parabola that passes through the points -1, -3, 0, 3 and 221. So we're finding the equation of the parabola. So we know a parabola is a quadratic function and it has the general form y equals ax squared plus bx plus c. So we're going to use this today and we're going to substitute our points in order to find our equation. So what we're going to do first is we want to substitute in any of the points, but the first point that we want to substitute in first is the one that has the x value as 0. So the one that has the x value is 0 is the point 0, 3. So we're going to sub in 0, 3 and it has its x value as 0. That's why we're substituting it in. So when we substitute this in, we get our y value is 3 equals a times our x value of 0 squared plus b times our x value of 0 plus c. So therefore, we have that our c will equal 3 because our a times 0 cancels out and our b times 0 cancels out. So all we're left with is c equals 3. Therefore, we now have the equation y equals ax squared plus bx plus 3 as our c value. So now we're going to substitute into this equation. Okay, might make that highlight a bit bigger. So what we're going to do now is sub in another of the values. So sub in our first value of -1, -3. So when we substitute that in, our y value is 3. So -3 equals a times -1 squared plus b times -1 plus our c value of 3. So we have -3 equals a times -1 squared is just a. B times -1 is -b plus 3. We're then going to minus our 3 to the other side of the equation and rewrite it so that our pronumerals are on the left hand side. So we have a minus b equals -3 minus 3 is -6. We're then going to plus our b to the other side of the equation. So we have a equals b minus 6, just so that we have this in the form of a equals something. And we're going to call this equation 1. We then are going to sub in our other point. So we're going to sub in our other point of 221. So we'll have 21 equals a times 2 squared plus b times 2 plus our c value of 3. So we get 21 equals 4a plus 2b plus our 3. We're then going to subtract our 3 from both sides. So we get and rewrite our equation with our pronumerals on the left hand side. So it will be 4a plus 2b equals 18. And we're going to call this equation 2. Now we have our two equations. We're going to sub our equation 1 of a equals into equation 2. So wherever there's an a in equation 2, we're going to substitute it with b minus 6. So we have 4 bracket our b minus 6 plus our 2b equals 18. So we're now solving this for b. So we have 4b minus 24 plus 2b equals 18. So I'm going to collect like terms. So I'm going to plus our 24 to the other side and collect our b's up together, meaning that we have 6b equals 42. And then I'm going to divide both sides of my equation by 6. And doing so, I get b equals 7. So therefore, now that I know my v value, I can use this to find my a value. So therefore, I'm going to sub b equals 7 into equation 1 because it's an a equals. We're trying to find a. So it'll be a equals our b value of 7 minus 6. So our a equals 1. So therefore, we have found that a equals 1, b equals 7, and c equals 3. So we're going to substitute them into our equation. So the parabola, the equation, of the parabola is y equals x squared plus 7x plus 3. So all we did there was substitute our a, b, and c into our general form of y equals ax squared plus bx plus c. Moving on to example 2, we have a parabolic satellite dish is built so that it's 30 centimeters deep and 80 centimeters wide. We want to find the equation for the parabola. So what we're going to do in order to find the equation for the parabola, we're going to first sketch this to sort of see what it would look like. So we have a parabola that is 80 centimeters wide, 30 centimeters deep. Now it doesn't say whether our satellite dish is facing concave up or concave down. For the sake of this, I'm just going to do concave down. Okay, so that was a bit dodgy. Let me try and draw that again. Oh, even dodgier. Far out. I'm doing a great job, aren't I? Okay, there we go. So that's our parabola. So we are told that it is 30 centimeters deep. So that means between here and here is 30 centimeters. And we are also told that between here and here is 80 centimeters. So because we have a parabola, what we can do is we can put it on a coordinate plane. So we're going to draw our coordinate plane. And so we have our y and our x. And so because our parabola is symmetrical, and because parabolas are symmetrical, we know that this point here is going to be the same distance away from the origin as this point over here. So we'll have our x value here of 40 and our x value here of negative 40, and our height of our parabola will be right on x equals 0, and it will be of 30. So we now have the points here. So we have our intercepts, so our x-intercept and our y-intercept we have found. So we know that our parabola passes through the points of 0, 30, 40, 0, and negative 40, 0. So we're going to sub these in to our general form equation of a parabola, y equals ax squared plus bx plus c. So we're first going to sub in the one that has x value equals 0. So we're going to sub in 0, 30 into our equation. So we have 30 equals a times 0 squared plus b times 0 plus c. So we therefore have c equals our 30. And so we therefore have our y equals ax squared plus bx plus our c of 30 as our equation that we're now going to substitute stuff into now that we've found our c value. So let's sub in our point 40, 0. So we have 0 equals a times 40 squared plus b times 40 plus our c of 30. So we're just going to move everything to the left-hand side of the equation. So we have 1,600 a plus 40 b equals 30, plus 30, sorry, equals 0. And we're going to call this equation 1. And then we're going to sub in our negative 40, 0. So we have 0 equals a times negative 40 squared plus b times negative 40 plus 30. And let's move everything to the left-hand side of the equation. So we get 1,600a minus 40b plus 30 equals 0. And we're going to call this equation 2. So because we have both equations equaling 0, we're going to say let equation 1 equal equation 2. So therefore we have 1,600a plus 40b plus 30 equals 1,600a minus 40b plus 30. And so we're going to move everything to the left hand side. So we're going to we're going to minus 1,600a, we're going to plus 40b, and we're going to minus 30 to both sides of the equation. So 1,600a minus 1,600a cancels out. 40b plus 40b makes 80b, and 30 minus 30 is 0, and this all equals 0. So therefore, because 80b equals 0, therefore b will equal 0. So I'm just going to bring this up here. So we're going to sub now our b equals 0 into equation 1. Either 1 or 2, doesn't really matter. So we have 1,600a plus 40 times 0 plus 30 equals 0. We're going to minus our 30 from both sides of our equation. So we have 1,600a plus 40 times 0, which is just 0, equals minus 30. We're then going to divide both sides by 1,600. So we get a equals minus 30 over 1,600, which cancels down to minus 3 over 160. So therefore we have our a equals minus 3 over 160. We have our b equals 0, and we have our c equals 30. And we're going to sub them into our equation. And so we go, therefore, the equation of our parabola is y equals our a value, so minus 3 over 160 x squared plus bx, so plus 0x, so that just cancels out to be 0, plus our 30, and that is our answer. Moving on to B, we want to find the depth of the dish 10 centimeters out from the vertex. So if we look back at our equation, our vertex is the point here. It is the point at the very top or the very bottom of our parabola. So it is the point 0, 30, and we want to find our the depth 10 centimeters out. So if we go 10 centimeters out, it would be here at x equals 10, or it could be the other way at x equals minus 10. So we could sub in x equals 10 or x equals minus 10. So we're going to sub in x equals 10 into our equation that we've just found. Sub in x equals 10. So we will get y equals minus 3 on 160 times 10 squared plus 30. And so we can enter that straight into our calculator. And when we do, we get y equals 28.1 0.125 centimeters. So therefore the depth of the dish is 28.125 centimeters. Now it's really important we write a concluding statement as it tells the marker of our work what the answer is and what we found, instead of just this random y value of 28.125. So now that we have finished the theory notes, if you're following the Margaret Groves Maths in Focus textbook, if you're following the advanced textbook, you would then be doing exercise 311. And if you're following the Extension 1 textbook, you'll do exercise 412.